So in this problem, I'm asked to calculate the solubility of calcium fluoride in pure water and also in 0.008 sodium fluoride. And I'm asked to use the KSP data that is in the Alex data tab. So the first thing I'm going to do is look up KSP for calcium fluoride, and that was 3.45 by 10 to the minus 11. So if I think about the KSP expression for calcium fluoride, it's going to be CF2 in equilibrium with Ca2 plus and 2F minus. So at equilibrium, that would have concentration X, and that would have concentration of 2X. Now that would be the case if we were beginning with pure water as our solvent. We didn't have any fluoride ions present. So in this case, KSP is going to be equal to our concentration of calcium ions, which is X, multiplied by our concentration of fluoride ions, which have to be squared, which is 2X squared, and that will end up being 4X cubed. So what you can see, I'm just going to make this a little smaller, is that KSP on 4, if we take the cube root of that, that is going to give me X. So let's go ahead and do that. So cube root of KSP, which was 3.45 by 10 to the minus 11 in this case, divided by 4 equals 2.051. That's 4 significant figures. That's going to be plenty, times 10 to the minus 4, and that's moles per litre. So that's okay, except for they've asked for the solubility in grams per litre, so we're going to have to convert it from moles per litre to grams per litre. So 2.051 by 10 to the minus 4 moles per 1 litre times by, and then we're going to need to have moles on the bottom here, grams on the top, and that's just the molar mass, isn't it? So now I go ahead and calculate the molar mass of calcium fluoride. 40.08 plus 2 times 19. There we go. So the molar mass of calcium fluoride is 78.08 grams for every 1 mole. So I just take the answer that I got before and times it by 78.08. So let's see what we got here. This ends up being 1.6 by 10 to the minus 2. Moles is gone, grams per litre. And so that's my answer for the first part of this question. It is 0.016 grams per litre. Okay, so the second part of the question is what is the solubility in 0.008 molar sodium fluoride. So let's just get rid of this and make a little bit of space here. We should make a note that the molar mass was 78.08 grams per mole, just so we don't lose that information. Okay, so in this case, we are beginning with 0 of this, and we have 0.008 of this, and then it's going to come into equilibrium, so this will go up by X, and this will go up by 2X, so we'll end up with X, and then 0.008 plus 2X of my fluoride ions. So now KSP is going to be equal to X multiplied by 0.008 plus 2X all squared, and then that will be equal to 3.45 by 10 to the minus 11. So I think the easiest way to go from here is to use the solver to get X. So that's what I'm going to do. You can use Wolfram Alpha, or you can use the solver on your calculator to do this. So I'm going to just use straight up Solvent Solver. So give me a moment here. And then for my x, I'm just going to put in that it is a small number. For my guess for x, okay. And I got that x was equal to 5.389 by 10 to the minus 7 moles per liter. So now I have to turn that into grams per liter. So 5.389 by 10 to the minus 7 moles in 1 liter times 78.08 grams in every 1 mole. So moles cancels out, leaves me with grams per liter. So I'm just going to do that now. 78.08. My answer ends up being, remember we want 2 sig figs, 4.2 by 10 to the minus 5. So I'm going to have to put that in scientific notation, 4.2 by 10 to the minus 5 grams per liter. So the adding the sodium fluoride radically reduced the solubility, which is what we would expect if we add fluoride ions. It's going to push the equilibrium to the left.